So in this presentation, we'll introduce our last logic rule, which is wedge out, and then we'll go over the first set of practice problems. This lecture and the next one in which we do the practice problems, there will be less than usual because these are extremely hard and extremely long problems to complete. So we're going to do fewer of them. I just want you to focus on them and just keep on practicing them. So for every rule that we've done so far in the course, there's either been one or two lines to cite. So if you know with and out, we can write any one of these from just one line. Some of them require two lines, like arrow out. You got one and two arrow out. So that requires two lines. You got one line, two line. Well, wedge out is the only rule that requires three lines. It requires three different components to do wedge out. They are the wedge that we're going to wedge out on, the conditional statement in which we take one side of the wedge and we show that it gets to the conclusion, which I'll show you here in a second. Then we got to do the other side of the wedge, which shows that it leads to the same conclusion. And then we have to do, or from that we can derive the conclusion itself. And hopefully as we do these practice problems on the next couple of slides, it will make sense rationally why the rule is set up this way. But if you have P wedge Q and you're looking to prove, let's say, T, you'll have a couple other things that are going to, a couple other premises that get to it. But what you would need to show is you would need the wedge statement. You would need to show that P gets the T and Q gets the T, and then you would cite all three of those lines and wedge out. So I'm not going to show you a problem on this screen because all of the wedge out problems take many, many lines. So we'll just start with the first problem on the next slide. So this first problem is as basic as it gets. We'll never have another wedge out rule or another wedge out proof that is as easy as this one. But for a wedge out, what we're looking for is to get to the conclusion. And it's difficult for wedge out because there's no inclination that you're going to have to use wedge out by looking at the conclusion. The conclusion is just a single letter by itself. So what we're looking for in this proof is, first off, a disjunct that's given to us, which we're already given this disjunct here in our first assumption. So check mark there. We're also looking for each disjunct leading to the conclusion that we're trying to prove. And the reason being is that if you have a wedge, it's saying either one of these are true. One of them is true, maybe both of them are true, but one of them is true. So if you wanted to prove that a certain conclusion comes from a disjunct regardless of which one is true, what you need to show is that both disjuncts, meaning both sides of the wedge, here, and I'm going to do a different color, and here, so you got P as the antecedent in one, you got Q as the antecedent in the other, both of them lead to the same conclusion, namely T. And here in our proof, we're already given them. Here is this one, and here is the other one. So we have all three pieces that we need to cite. So since we have all three pieces, we can assert T, which is the conclusion, and we'll cite all three lines and wedge out. Now, we won't do one as easy as this, but this just shows you the pieces that you're needing. You need a disjunction. You need a wedge. And from that wedge, you need the conditional statements in which they show that if you had if you have one of the disjuncts, they lead to the conclusion. If you have the other disjunct, it leads to the same exact conclusion. We have that here. So this is the most basic version of the proof. Let's do some more difficult ones. So here in problem 2, we have another situation in which we have a disjunction, and we have a conclusion that is just a single letter, S. And there's no way to get S from the different premises that we have given to us, and so there's a pretty good idea that we're going to have to use wedge out because we have a disjunction in one of our premises right here. So what's that telling me that I need to find? Well, I need to find the arrow that leads to S for both P and Q. Now, we don't have that. So we're going to have to build each one of these arrows before we can use our wedge out rule. So, how do we prove an arrow? Well, we have to assume the left side as a PA and look to prove the consequent. So, let's do this one first. So, we'll assume P, and from this we can get T and S from 2 and 4, arrow out, 2 and 4. We can get the S out because that's what we're looking to get to from 5 ampersand out. Now we've got to our consequent. We can build our arrow from 4 and 6, arrow in, 4 and 6. The 2 will drop out because we're doing arrow in, so that gives us this one. So we have 2 pieces so far, we just need the third piece. And we're going to do the same exact thing. We're going to assume Q as a PA and look to prove S. So we can toss this Q into the conditional statement in 3 to get S and R. So that's from 3 and 8, arrow out, 3 and 8. Then we can remove the S because that's what we're looking for from 9 ampersand out. Now that we have that, we can build our arrow from 8 and 10, arrow in, 8 and 10, the 3 will drop out because we're doing arrow in. And now we have our other conditional statement. So I have all the pieces that I need. I have P arrow S here. I have, let's do green, Q arrow S here. I've got my P, that wasn't the same blue that I used before. Let's see if I can pick it out. And we got a P or Q in line 1. So what we'll do in line 12 is just assert S and cite 1, which is my wedge, 7, which is one of my conditionals, 11, which is another one of my conditionals, and wedge out. You have to cite all 3 of them. And then what we'll see is that we have all of our premises, 1, 2, and 3. And so that's it. But we're looking for 3 pieces, and it's best when we do wedge out to have a certain uh, plan ahead of time by looking for our 2 conditionals and identifying our wedge. So problem 3 here is similar to problem 2. We have a wedge as one of our premises, and we have just a single letter as our conclusion, which tells us we probably need to use wedge out. So we need to find P arrow S and Q arrow S. S is the conclusion that we're looking for. That's why we are building arrows towards S. So we need to get to both of those conditional statements. So to prove them, we just need to do the separate arrow introductions to build them. So again, we'll assume P, which is one of the disjuncts on our wedge statement. We'll assume P and look to prove S. So what we need to do to prove S, given that we have P, is wedge in our T first. So from 4, wedge in, 4. Then we can eliminate the arrow by doing 2 and 5, arrow out. 2 and 5 is 2 and 4. Now we reach the conclusion we are hoping to get to. We can arrow in, and that would be from 4 and 6, arrow in. The 4 will drop out because we're doing arrow in, and that's one of our conditionals that we are looking for, so that's that one. Now we just need to do the same thing to get the Q arrow S, and we'll just wedge in the R, and that would be from 8, so 8. And then we can toss that into our conditional statement in 3, so 3 and 9, arrow out, 3 and 9. Then we can do Q arrow S from 8 is our PA, 10 is the consequent, we're doing arrow in, 8 and 10, that means, oh, sorry here, didn't mean to do 9, do 8. So that means our 8 will drop out, so that just leaves us with a 3. And that is our other conditional statement we are looking for. So given what we have, we can assert S from 1 is our disjunction, 7 is one of our arrows, 11 is another arrow, and we are not doing arrow, we are doing wedge out. And then we just need to cite 1, 2, and 3, because those are all the premises that are associated with it. Don't need the 13. So that's problem 3. Very similar to problem 2. Now we're going to add a little bit of a wrinkle. So here we have another disjunction, but this one it's a little bit more complicated because it's P and Q or S and T. And then we have just a single letter as our conclusion. So what we're going to need to find are the conditional statements that lead to that conclusion given the two disjuncts that we have. It's going to be the same exact process as before, but now we just have a little bit more, we have this ampersand in each of the disjuncts. So same thing as before. We already have the disjunction given to us here. So we need to prove the other two conditional statements. So we'll assume P and Q as a PA, and we'll look to prove R. And again, the reason why we're proving R is because that's our conclusion. Conclusion will always be the consequent of the conditionals that you are building. So with this PA, we could split it up into P and Q, both coming from 4 ampersand out. Then we can toss our P into our conditional statement in 2. So 2 and 4. Then we can toss the Q into this conditional statement to get that. And then we can, actually no, right there we have our R. So we can build our conditional statement that we're looking for from 4 and 8, arrow in. 4 and 8 would just be 2, because the 4 will drop out. So that's one of our conditional statements that we are looking for. Now we just need to restart and get the S and T arrow R. So we'll mark it as a PA. And we'll do the same thing as before. We'll split those up, so that'll come from 10 ampersand out, 10 ampersand out, 10 and 10. Then we can toss the S into the conditional statement and 3 to get T arrow R. So that would be 3 and 11, arrow out. 3 and 10. Then we can toss the T into this conditional statement to get R. So that'd be from 12 and 13, arrow out. And now we got to R, so we can just build our conditional statement. So that would be S and T, arrow R. And that will be from 10 and 14, arrow in. 10 will drop out because that's our PA, and there is our third conditional statement that we were looking to get to. So now we have all of our pieces, so we can just assert R, citing 1, 9, 15, wedge out, and that's going to be 1, 2, and 3. So that's problem 4. This one's a little bit more involved, but it's just to show you that even if the disjunction is a little bit more complex, you just assume everything on that side of the disjunction and work towards the conclusion that you're trying to get to. So here on 5, this gets a little bit more complicated because immediately you might not see your disjunction, but really it's hiding in this ampersand. So what we need to do is we need to remove it from line 1 first. And so that'd be from 1 and out. And now we can sort of see where our pieces for this wedge out are going to come from. My disjunction is P wedge S, so I need to find P arrow T, S arrow T. So again, that's just saying that I have 2 disjuncts, and they both need to show me that they get to the same conclusion, namely the conclusion we're looking for in the proof. So let's try to prove those by assuming the antecedent for both of these. So we'll start with P arrow T. So we'll assume P is a PA. We'll look to prove T. So from P, we can ampersand in the R. So that'd be from 5 and 6, ampersand in. 5 and 6 are 1 and 6. Then we can toss that into the conditional statement in 2. So that would be from 2 and 7, arrow out. 2 and 7s, 1, 2, and 6. Now we got to the conclusion that we were hoping to get to, so we can arrow in and do P arrow T. From 6 and 8 is going to be arrow in. So now we have 1 and 2. The 6 will drop out. That's our conditional statement that we're looking for there. Now we just need to do the same exact thing for this S arrow T. We'll assume S, and we can mark that as PA. And then we can ampersand in the R from 5 and 10, ampersand in. 5 and 10, we'll have 1 and 10. Then we can get our T out from 3 is our conditional statement, and 11 is our antecedent. So that would be arrow out. 1, 3, and 10. Now we got to the conclusion we were hoping to get to, and it depends upon our PA, so we can do S arrow T from 10 and 12, arrow in. 10 is our PA, so it will drop out, and now we got this one, and so we can just assert T from, let's see, let's go ahead and color coordinate this like we have been. So P arrow T is here. P or S we already identified, and then we just need to get this one here, which is right here. So we could cite line 4. So 4 is where our wedge is. 9 is where one of the conditional statements are or is, and 13 is, don't want to do arrow, edge out. And so that will be from 1, 2, and 3. The other ones we don't need. But key points here. Even though the wedge appears in this PA, or sorry, in this assumption, we need to cite the line in which it appears on its own. So we have to cite line 4, not line 1. That's usually a common mistake. But the rest of it is pretty much in line with everything else we talked about in the previous slides. So that is problem 5. So I have a feeling this one's going to be super long because in this instance, we do need to look at our conclusion. Our conclusion is no longer just a simple letter. It is a conditional statement. So whenever we have a conditional statement as our conclusion, you know that we need to make a PA of the antecedent and look for the conclusion. So we assume P and look to prove R and T. Well, here becomes the interesting part. And this is one of those instances in which you might just want to go ahead and start working the problem at this point and see how far you can get before you get stopped. So here we can toss the P into our conditional statement in line 1. So 1 and 4, arrow out, like that. And then, now we're going to be stuck. But you should realize that I have a wedge in Q or S, and so I might need to do wedge out. Well, let's look at the conclusion again. What am I looking to conclude now? I'm looking to, like, the ultimate conclusion is this, but I assumed this to derive this. So this RNT is going to be the conclusion I'm looking to get to derive from each one of my disjuncts. I'm looking to prove Q arrow RNT and S arrow RNT. So we're going to have to do each one of those separately. And then once we get to that proof, we're going to prove RNT, and then we're going to arrow in with our PA. So let's just do this one step at a time. Like I said, these are much more complicated than the other proofs that we have done previously. I think wedge out is by far the hardest rule, which is why I do it last. So here is my disjunction. I want to prove each one of these conditional statements. So I'm going to make another PA here at 6 and look to prove R and T. So I can put Q into 2 and get R and T. From 2 and 6, arrow out. And that one is not too bad because I can go ahead and build my arrow. Actually, I didn't even need to have to do all that. So luckily, and maybe I should have paused, but this is a good teaching point, but I already actually had this conditional statement right here. So I didn't really need to prove it. That was a little bit more helpful than I was wondering why I was just about ready to write arrow in and write the same thing I just had. So we don't need to do that conditional in, which is nice, but we still need to do the other one. So we need to assume S as a PA at 6. Then we can toss that into our conditional statement in 3. So 3 and 6, arrow out, 3 and 6. Now we have to do this one because we need to split the T and R apart and put them in the right order. Have to show all of our moves. So we have this. Now we should put them back together as R and T. 6. Now we can build our conditional statement S arrow R and T from 6 and 10 arrow in. The 6 will drop out. And now that's the other conditional statement we are needing. And so we can assert R and T from 2, 5, and 11. Edge out. 2 has 2, 5 has 1 and 4, and 11 has 3. So 1, 2, 3, 4. But we're not done yet because we need to arrow in with our P. And so that's going to be 4 and 12, arrow in. And that'll be 1, 2, and 3. This one wasn't as long, but you can imagine it would have been longer if we had to build the Q, arrow, R, and T ourselves if it wasn't already given to us already. But here we see another wrinkle in which the conclusion isn't just a single letter, it's a more complex conclusion, and we have to assume the antecedent and prove the consequent, and we're proving the consequent by doing a wedge out. So I know, very difficult, but make sure you review this and understand the thinking behind it. This last one isn't so bad because I've already given us our conditional statements that we're ultimately going to need. But there's a wrinkle to this one as well, which is why we're finishing with it. So again, don't want to get out of our habit of looking for the main operator in the conclusion. The main operator is the arrow, so we need to assume P or Q and look to prove our consequent. So that will be a PA as 3. And now we see we have a wedge. So we have a wedge. We need to prove that both of these disjuncts lead to the conclusion. You need to find that P leads to T and Q leads to T. Now, luckily, we are given those as premises, so we don't have to do too much work here. But this shows you how when you start a proof, like this one with a conditional, that you might already have the information that you need, but you're going to work yourself into a wedge out situation more than likely. So we have the wedge here in 3. We have both of the conditional statements that we need in lines 1 and 2. So we can just assert T from 1, 2, and 3, wedge out 1, 2, and 3. And then we still need to do our arrow in. So we can arrow in on our PA, 3, and 4, arrow in. And then 3 will drop out, so it's just 1 and 2. So not too hard to finish out the practice problems here, but it shows you the beginning stages of, let's look at the conclusion. The conclusion, the main operator is an arrow, so we know to assume the left side. Well, our left side is a wedge, so we might be using that for a wedge out, and then as we use it for a wedge out, we'll just look to prove T and arrow it back in. So the next set of practice problems, we'll do 8 of them in the next lecture. They'll be a little bit more, maybe a little bit more difficult than these. Probably most of them will be double-digit lines long. But this will conclude this lecture. And again, if you are a little bit uneasy about this, that's all right. This is the most difficult rule. And so just keep reviewing this lecture and the next lecture.